Hello, I'm Captain Dan Kiggins here at NASA's Langley Research Center with two of NASA's senior human factors researchers, Dr. John Holbrook and Dr. Lance Prinzell. Welcome, gentlemen. In the face of an increasingly autonomous future, it's reasonable for pilots to wonder what the human role will be. Dr. Holbrook, perhaps you could speak to what the human element is, and as I understand it, there's a forthcoming experiment that will involve 24 American Airlines pilots here at Langley.
Yes, thank you, Captain Kiggins. First, let me assure our audience that humans will continue to play a vital role in aviation safety for the foreseeable future. Too often, when we think about the human element on the flight deck, we focus only on the human errors that happen rarely, and ignore the everyday adjustments that flight crews make to keep operations safe. The human contribution to safety, as we call it, is intended to capture and describe what human flight crews routinely do right. For instance, knowing when to ask for help, sharing knowledge with a less experienced pilot, communicating expectations for a flight, coordinating divisions of tasks during times of high crew workload, are just a few of the things that humans do, things that incidentally are a struggle for automation. The main idea here is that we want the airlines to make policy decisions that are informed by data, but we can only learn from the data we collect and analyze. Flight crews take positive actions that make things go right, but if we aren't systematically capturing that, we can't systematically learn from it. And if we only collect data on things going wrong, and all we know about flight crew behavior is how they fail, this affects the conclusions we make from the data. We've probably all heard that human error is implicated in 80% of accidents in aviation, but we rarely hear about how flight crews take actions to maintain or create safe conditions. And this is ironic, because a recent analysis by NASA estimated that pilots intervene with automation to keep flight crews safe over 157,000 times for every time that human error contributed to an accident. American Airlines is already pioneering efforts to capture operational data about these kinds of crew capabilities through its Learning and Improvement Team observations and interviews. And here at NASA, we'll be conducting a study in our research flight simulator where crews will fly several scenarios that should be manageable for a collaborative crew, but would be problematic for automation alone or for crews that aren't working together. But regardless of what kind of performance we see, we're identifying ways to learn from what happens, to learn what to avoid when things go wrong, and to identify what we want more of when crews perform well. One of the primary goals of this study is to further our understanding of how flight crews work collaboratively to plan for, adapt to, and coordinate about the changes that are happening around them.
Well, thank you, John. And Dr. Prinzell, speaking of collaboration, in your many years of research, what attributes would you expect to find in the most successful crews?
Thanks, Captain Kiggins. As you can imagine, it's not necessarily the high performers or the right stuff pilots, but rather the most collaborative. An average crew with a strong rapport generally outperforms a crew with two high performers with limited interaction. It makes a strong argument for establishing the connection in advance, at the gate for instance. We've seen this in other startle surprise scenarios we've used in NASA research studies, one of which was at the Boeing Flight Academy in Miami. We used a 787 and induced startle with a dual compressor failure on departure from Quito as a result of volcanic ash penetration. The loud bang of the compressor, followed by an avalanche of ICAS messages, basically saturated the crews. They wore a suite of biomedical sensors, so we were able to capture their physiological response. The most collaborative crews were least affected by the startle and the most successful in resolving the situation. As they were all low time and newly type rated in the 787, they were very dependent on each other for a successful outcome.
Well, Lance, speaking of startle and surprise, can you differentiate between them and explain the differences in response to visual versus audible startle?
Yes, absolutely good question. Startle is a reflexive response to an unexpected stimulus. Surprise may not elicit startle, and there is minimal physiological reaction. Crews may express surprise, but maintain composure. Startle, on the other hand, can be like a flash bang grenade. Sound is processed by our brain quickly because there are significantly fewer steps to process it than visual stimulation. Sound is processed and decoded by lower-level areas of our brain, such as the brainstem and thalamus, resulting in rapid uptake of information. Sight, on the other hand, is far more complex to process and has done so in our occipital cortex with vast connections to the frontal cortex and hippocampus, where we maintain complex memory. Therefore, sight and sound can have different impact on a crew, and as a result, on their performance. Realizing that individuals are affected unequally, we can begin to appreciate the role of the other pilot, whether they are the monitoring pilot or the pilot flying. They may well be in a position to quickly redirect or refocus their fellow crew member to yield a positive outcome, assuming they establish a working connection in advance.
Well, you mentioned NASA research that has shown the importance of startle and surprise, which could impair performance of flight crews, but have there been any real-world examples of this?
Yes, startle and surprise have played a role in many worldwide commercial aviation accidents. One accident that many pilots are familiar with is the 2009 Air France Flight 447 accident, where ice crystals obstructed the aircraft's pitot tubes, causing inconsistencies in airspeed instruments, ultimately resulting in autopilot disconnect. There were many factors involved in that accident, but one of those was the first officer's initial response to pull back hard on the side stick. That was consistent with what you would expect with impaired information and cognitive processing, decision-making, and problem-solving, expected to be seen with a startle response. Furthermore, the continued, persistent full-back pressure suggested multiple startles and continued degraded information processing following the startle. The chief investigator for this accident was said to have equated it to curling instinctively into a fetal position. So, as you can see, startle and surprise can be a difficult thing to overcome, and pilots should be aware that they are all vulnerable to it.
Well, thank you, gentlemen, and thank you to our audience for your attention. As you've heard, NASA is here to serve and support you.